So I went ahead and created a new account, and we'll spend some time to set up the cluster on this, and then we will look at the other topics. So in this case, I'll be using COPS. So did I cover COPS, setting up cluster using COPS?
Minikube, you did Minikube, not COPS.
Before this Kubernetes, I had done Kubernetes earlier also, right?
Yeah, that time you had covered. So we were yet to start Kubernetes volume.
Correct. But we had used COPS, right, to set up the cluster.
I don't remember, Ravi. It's been a long time.
Yeah. That's okay. So expires. That's fine. So let's go to domains. So here's my domain, and then let me quickly take this. So we'll have to sorry. So we'll have to set up COPS basically, and then using that COPS, we'll have to set up our cluster. So there are a few prerequisites that we will have to do. So let's see, create hosted zones. And let's call this as cube dot. Okay, so if we are going to set up the cluster using COPS, we will need to have a domain. Okay, so I'm using Hostinger in my case. If you can recall the Route 53, we had looked at your domain registrations and everything. So in my case, we're using COPS, and sorry, we're using Hostinger. Now to link my Route 53 with Hostinger, we need to add this NS records. So I'll go back here, we'll go to DNS or name servers, and here we'll need to change this. So there are 4 records. We'll have to add all the 4 records one after the other. So this is kind of creating a link between Route 53 and Hostinger. Okay, so my domain is registered in Hostinger and my name servers are in Route 53. Okay, so these are 2 different platforms. So adding this NS records will help us okay, so then we are inside the server and there are a few things that we will have to do. So let me see if I have the instructions somewhere here, maybe. Kubernetes. Okay, so cluster using COPS. So here's the instructions. This is what we'll have to follow. So first thing is installing COPS. So we can follow this link which has the instructions to install our COPS. So what is COPS? COPS is a tool which can be used to set up the cluster. Oh, looks like it's not there. Okay, I need to update that. So COPS install on Ubuntu. Okay, so let's see there. Okay, so let me quickly update this so that in case you are referring this, we don't have any issues. Okay, so I'll take this. So here, depending on your platforms, in our case, we're on the Linux. So we'll copy these instructions and we'll run this here. So this should install the COPS for us. You can validate by running this COPS. And if you see this, that means your COPS is installed. That's one. So that's your step 1. Once we have that, we'll update our machine. And we are going to install our CLI. Okay, so the AWS CLI. So kops, like I said, it's a tool which is used to set up the cluster on AWS. So kops will need the necessary permissions to create the resources on AWS platform. So that's where we're going to use the CLI. And then you can validate whether your CLI is installed or not by running this AWS -- version. That should tell you the version of CLI that we have installed. This is same as what we had done in your CLI session, AWS CLI session. It's the same thing. Installing the CLI tool, then we will need the access key and secret key for authentication. So let's wait for this to complete. And this is done. So let's validate. So there's my CLI version installed. Next, we will need to create an IAM user who has programmatic access. Okay, so basically we need the access key and secret key, basically. Okay, so let's go back. We'll go to the IAM service here, and we'll create a new user. So let's go to users, create user. So let's call this as Cube user, and we have to make sure we are giving it the programmatic access. We don't need the management access, that we don't need the console access. And then the permissions. We'll attach a admin, so we're giving it administrator access. Next, review this and then create user. Now, nowhere we got the access key and secret key, so we'll go here and under the security credentials, we should be able to see the access keys. So we will create a new set of keys. So what is your use case? So in our case, it's the CLI. And next, sorry, we'll have to confirm this. Next, create. So here is our access key and secret key. So now we will log in by using this access key and secret key. So to log in, we will be using your AWS configure command. So AWS configure. So this will prompt us for the authentication. So first we need to give the access key. Then we will give the secret access key. Then the region, in which region you want to create the resources. So in our case, we want to create this in US East 1. And then the output format would be JSON. So this will authenticate or give the necessary permissions. Once we have that, we will also need a bucket. Okay, so this bucket is where all the cluster related information will be stored. So we'll go ahead and create a new S3 bucket for this. So let's go here and let's search for the S3 service. So there's my S3 service, and let's go ahead and create a new bucket. So we'll create a new bucket, and it is for general purpose. So let's call this as cube. You can give whatever name you want. I think it won't take underscore, so I'll give hyphen, and we will create this bucket. So this bucket is where all the cluster related information will be stored. Then we have created the hosted zone. We have added the NS records. The final thing we will need is your kubectl. So can you tell me what is kubectl? What is the use of your kubectl? Anyone? Yes, no?
No, sir.
So kubectl is a command line tool. We use this to interact.
Yeah, inside that you run the commands.
Correct. So how do we interact with your cluster? We make use of your kubectl for that. Okay, so let's run these instructions one after the other. So we'll first download the binary package, then install. So here we will run this instruction, which should install the kubectl for me. And then, if you get permission error, you'll be running this command, and then you can validate whether your kubectl is installed or not. So there's my kubectl installed. Okay, so that's basically everything that we will need to set up the cluster. Then finally, we'll be running this command, which will generate SSH keys for us. So we'll just run that command. and done. Now all we have to do is set up our cluster. So here you should be able to see the command that we are going to use to set up our cluster. Okay, so here is the entire command. So basically what are we doing here is okay, I did not get that completely, so hold on a moment. Okay, so using cops, we are creating a cluster, we are giving it a name. Again, you can call it whatever you want. The bucket where the cluster related information should be stored. So this is where we created the bucket. So make sure you're using the right information. So here you can see that's the name. Then in which availability zones you want to create the instances, how many node machines you want, that is remote machines you want, what is the instance type, how many master machines you want, the size, default will always be one, and then your hosted zone name. Okay, so this will be the entire command. We will take this command and we will run this on the server, and this should begin setting up the cluster for us. This will ask us for a confirmation. Okay, so here, this is the preview. So here we will need to confirm this. So here we will need to run this update instruction. Only then it will start creating the resources for us. We'll also need to provide the bucket name with this. So here the state, basically we will need to provide this, and it's a confirmation basically, and this will start creating the resources for us. Okay, so you can see here now the resources are being created. So this will take like a few minutes, but the cluster should get created. So essentially what happens here is your cops will start creating the resources on your AWS platform. So here they should start launching 2 EC2 instances for me. Okay, so it will take some time, but yes, you can see cluster is starting. It should be ready in few minutes. And then you can do a validate, which will tell your cluster is created or not. Okay, so this will take some time, but this is one way. So you can see here the instances are coming up. So there is my control machine, and this is my remote machine, the node machine basically. Any questions with this?
No, sir.
Okay, cool. So moving on to the topics. So I guess we have to get started with your volumes. So let's go there. So same as your Docker. Okay. Okay. I also have to show you the dashboard thing, so I'll show that as well. But talking about your volume, so whenever you want to make your data persistent, so by default your data is not persistent. What I mean by that is the data is available as long as the container is running. If you stop the container or if you remove the container, the data is lost. Okay. Now, what if you want to make the data persistent? So what I mean by that is irrespective of the status, whether you stop the container, you remove the container, you want the data to be available. How do you do that? That's where we can make use of your volumes. So a volume can be thought of as a directory which is accessible to your container in a pod. So it's you can think of it as a folder which we are giving it to our containers, and then your container will start storing your data inside this folder. So we have different types of volumes in Kubernetes, and the type defines how the volume is created and its contents. So there are lots of volumes options. So the concept of volume, this was also present in Docker. However, the only issue was that the volume was very much limited to a particular pod. As soon as the life of a pod ended, the volume was also lost. Now, the volume that are created through Kubernetes is not limited to any container. It supports any or all the containers deployed inside the pod of Kubernetes. And a key advantage of Kubernetes volumes is it supports different kind of storage, wherein the pod can use multiple of them at the same time. So there are lots of options. So Kubernetes supports a variety of volumes. So one is your MTDIR. So this is a type of volume that is created when a pod is first assigned to a node. It remains active as long as the pod is running on that node. The volume is initially empty and the containers in the pod can read and write the files in the MTDIR volume. Once the pod is removed from the node, the data in the MTDIR is erased. So you can think of this as your temporary data, where the data is available as long as the pod is running. If you remove the pod, the data is also lost. Then you have your host path. So this type of volume mounts a file or directory from the host machine's file system to your pod. So like let's say in this EC2 instance, you have a path called var www.html. You want to mount that to your pod. We make use of your host path for that. Then you have your GCE persistent disk, which is your Google Cloud volume. So this type of volume mounts a GCE persistent disk on your pod. The data in a GCE persistent disk remains intact when the pod is removed from the node. So this is where your data will be persistent. So even if you delete the pod, the data would still be available for you. Likewise, you have lots of options. In AWS, we have the EBS, we have NFS, we have ISTSI, Flocker, Glutter EFS, RPD. So there are lots of options. I'm not going to go over everything, but at any point you want to make your data persistent, you have the volumes option. So in our case, I'll first show you an example for your MTDIR, how you can make use of the MTDIR. So here this repo, it has example for us. So this one. So what are we doing here is we are creating a pod. Okay. So inside this pod, we are creating two containers. One is we are calling it a C1 CentOS image, and then the other one is your C2 CentOS image. Here, this is the main thing that you'll have to look at. The volume mount name you're calling it as exchange and the path. So /tem/exchange and the same volume we are using it in a second container as well. And here is the volume that we are creating. So MTDIR is what we are using. So with this, essentially what we're going to do is we have two containers which will share the same volume. So whatever the data that we will create in one pod or one container will be shared by the other container inside the pod. And this data, it will be available as long as your pod is up and running. If you delete the pod, the data will also be lost. Does that make sense?
Yes, sir.
So let's see an example for this. Hopefully my cluster would be ready by now. So let me log into this once again. And we can validate our cluster to see whether it is running or not. So we can use kops validate cluster. I'll need to give the bucket name. So let me get the bucket name from here. And okay, so verification fields, you can see cluster is not yet healthy. So it takes some time, but yeah, as of now, only the control machine is ready. The node machines are not yet ready. You can also use this kubectl command. So kubectl get nodes. So this will tell you how many nodes you have. So you can see as of now, I have only one node, which is the control plane. Control plane is your manager machine. So this machine is ready to use. This is not yet ready to use. So it takes some time. While we wait for that, let's create a folder. So let's call this as mtdir. Let's go to that and let's create a volume.yaml file and we will give these instructions. Okay, so we'll save this and we will execute this. So kubectl create -f volume. So this should create a pod for me. And inside this pod, we will be having two containers. So kubectl get pods. So here you can see container creating. So it's been created and you can see 0 of 2. Just give me a moment. Hey guys, sorry. So let me log in here once again. So kubectl get pods. So you can see 2 of 2 running. And if you look at the details of this, so kubectl describe pod, the pod name. So this is basically the events, but here you can see this is your container C1 and here is your container C2. So basically there are 2 containers created. Now let's log into one of the containers. So here is the command we can use. Okay, so kubectl exec-it. This is the name of the pod. Inside this pod we have a container which is C1 and my interpreter. So this will connect to the first pod, and here if you see under temp, okay, this is where we have created our volume. So let me go here, and by for now if you see I don't have any data, so let me create a new file here. So let's call this as index.html and let me add some data to this. So let's say this was created from the first container. I know there's a typo, I'm going to ignore that. So I've come out of the first container and now we log into the second container. And whatever the data we created in the first container will be available in the second container as well. This is where mtdir can be used to share your volume between the containers running inside a container pod. Questions?
No, sir.
Okay. Next, we have your persistent volume. So this mtdir, that's one thing. We also can make use of your EBS volumes or any of your persistent volumes. Okay. So the persistent volumes are system. This provides an API for users and administrators that abstracts details of how storage is provided from how it is consumed. So to do this, there are 2 things that we will be using. One is your persistent volume and the other is your persistent volume claim. Persistent volume is to create the volume, and then persistent volume claim is to use that volume. Okay, so this persistent volume, that's your piece of network storage that has been provisioned by the administrator. So it's a resource in the cluster which is independent of any individual pod that uses the PV. It's your persistent volume. And then you have the persistent volume claim. The storage requested by Kubernetes for its pods is known as a persistent volume claim. So persistent volume is created by the administrators. Persistent claim is where the users will create it. Does not need to know the underlying provisioning. The claim must be created in the same namespace where the pod is created. Oopsie. I, I removed him by mistake. Sorry, Bharat. I wanted to mute you, but then by accident I removed you. Sorry. So yeah, so coming to your persistent volume. So here EBS is what we are going to use. Okay, so you can see here, this is where we are creating the storage. Okay, so we will take this and we'll create a storage class. So this will be my storage class. Then we have the PV, which is to create the volume. So here you can see we are creating a volume of 10 GB. If you have a volume already, you can give the volume ID. Okay, so let me take this and let's call this as pv.yaml, and we will go ahead and create a new EBS volume and we will give it to our PV. So let's go to volumes. We'll create a new volume. This is going to be of 10 GB, and I have to make sure that they are running in the same availability zones as my instances. If not, then I won't be able to mount them. So this is running in US East 1A. So I'll make sure that I create them in US East 1A, and then we'll create this volume. So this will give us a volume ID. So let me see which is the one. Okay, so here the last one. This is what we have. So I'll take this volume ID and we will give that here. So this becomes my persistent volume. Then we are going to create a claim for it. So claim. So this is basically telling that, hey, I want to use the persistent volume that is created. So this will be pvc.yaml. So here, if you see this one, the metadata, this name, this is what you'll have to look at. Okay, so let me show you here. So if I read everything. So this is my persistent volume that I have created. This is the claim that I'm doing. For which storage? For this storage. So this you can see a EBS SC. There's my EBS SC. Okay, and then finally we are going to have our pod. So here we are going to create our pod, and pod, and then image is sent to us. We are running some command, and then we are mounting our volume. So what is the name of it? Persistent-storage, where we are mounting it, and then which volume we are mounting. So that is what I have PVC here, EBS-claim. Okay, so I have everything now. All I have to do is create this. So we'll execute all the files at the same time. So kubectl create -f star. Unexpected. Okay. Pod PVC storage. I guess I'll have to. Oh, I have to do an apply. Sorry. kubectl apply -f star. Oh, okay. So in that case, I'll have to create individually. Earlier it used to work, but I guess they have removed it. So we'll first create our storage. Then we will create our PV. Then we will create our claim. And then finally we will create our pod. Okay, so 4 resources. So kubectl get sc, which is your storage class. So here, this is what we have created. Then kubectl get pv, which is your persistent volume. So this one, this is what we have created. Then kubectl get pvc, which is my persistent volume claim. And then kubectl get pods, which is my pod. Now, if you look at this, so kubectl describe pod and the pod name. Here you can see the volumes. Okay, you should be able to find the information. Now, if I log into this, so kubectl exec -it, and then let's use bash. Okay. /bin/ okay, and here you should be able to see this folder data. Okay, so if you look at this, okay, so we are creating this file called, in the data folder we are creating this file called out.txt, and we are basically doing an echo. So if you look at this file, you see here, this is basically the date and time we are doing. So you can see a $date. So the data, basically whatever we have mounted it to the data. Now even if this pod gets deleted, okay, so let's say this pod gets deleted, the data would still be there for me because we are storing it in the EBS volumes. So this is how you can make your data persistent. Make sense? Questions?
So later we can use it for another pods, right?
Correct.
Okay.
So let's say delete, and then let's say the pod, right? So the pod would be deleted, but the data would still be available for me. So if I create the pod once again, we are simply mounting the same, or it could be in a different configuration file altogether. Anyway, it is possible. That's totally up to you. But yeah, whatever you said is correct.
Okay.
Okay, so pretty much that's all I have. I have one last thing pending, which is your dashboards. I will show you tomorrow, and that should complete your Kubernetes. Again, I mean, this is not the end. Kubernetes, again, it's very huge. There are many things that you will need to learn when we talk about your Kubernetes, but at least this should give you an understanding of what it is, how you can, so you can see now this is deleted. So let me quickly create this again. And if I log into this, okay, so that's running now. So let's log into this, and if I go to that folder, here is the file, and you see I already had this much of data. Okay, and now I have the additional data. So I have the old data as well, I have the new data as well. That's basically a persistence. Questions?
No, Ravi.
No, sir.
I'm gonna stop here. Tomorrow I'll show you the dashboard thing. I've already shown, but I'll show it once again, and that should complete your Kubernetes. And if time permits, we will start off with your monitoring. That's the last thing that will be pending. So as part of your monitoring, we will be looking at your Grafana and Prometheus. Obviously, there are many tools when we talk about your monitoring, but in our case, we are going to look at your Grafana and Prometheus. Okay.
Fine, Ravi.
Thanks a lot, guys. I'll see you tomorrow.
Thanks, Ravi. Take care.